Hello everyone. I decided that I would record a video of my implementation of the model and the data access layer in Project 2 because a number of students are having problems with that because they have very little experience with database programming using SQL in general, or the sometimes weird SQLite database interface that Android uses. So I'm going to start by creating a new package for the model. And the first class I'm going to create is class to represent my user. And users have email addresses, which are their primary login name, passwords, full names, and I'm making the same mistake I always make and forgetting to go with naming conventions, having my member variables start with the M prefix. Users have a birth date. SQLite doesn't support dates, so I'm just going to go ahead and use the standard Java util date for this instead of the Java SQL date. What else do users have? Oh, they have a profile pic, which I'm going to save as a string that points to a file. Okay, now that I've added all of these attributes to my user, I'm going to go ahead and use Alt Insert to generate getters and setters, holding the Shift key down to select all of the options and then hitting Enter to generate getter and setter code. Next, I am going to create a parameterless constructor. I don't know if I will need to use this later, but I'll add it just in case. So we also need feed item. These are going to be the tweet-like items that users will be able to create and browse. Feed item has an email address, which is the person that posted the item, has some textual content, and it has a optional photo. Users can post photos as part of their posts. It also has a date and time that it was posted. Hit Alt Enter again to import Java util date. And I'm sure there are other attributes that the feed item should have that I'm forgetting right now, but I'm going to use Alt Insert again to generate getters and setters for these 4 attributes. Okay, so now my feed items have an author, they have a date that they were posted, and they can have textual and photo content. I'm not going to generate another item to represent favorites, or another model class to represent favorites, because that'll exist just in my schema. Okay, so I'm going to create another package called database, and this is where my schema will live. I'm going to create a new class called schema. Every schema needs database name. Sorry, this should be final. This is the name of the database that will be the SQLiteOpenHelper that I'm going to create in a few minutes. Will check for a file in a specific location in Android's storage for the specific app, and if it does not find a file with that name, it will create one, and that's where the database will be persisted. If the file already exists, then the database will be loaded from there. So I'm going to call it project2.db, and going to save a version number as well. Version numbers tend to not change very often, really only when an app has been released and has users, and for some reason you need to change the schema of your database, then you'll want to change the version number. Otherwise, it's pretty much always going to be 1. It'll be 1 for any project that we do in this class. So in a little bit when we get to the SQLiteOpenHelper. We're not even going to bother implementing the upgrade method. Okay, so I've got 3 tables to store the different types of data in my database. The first one stores users. I'm going to add the name of the table. As a constant to the class, and then I'm going to create an inner class to my inner class that stores the column names. Now I'm going to need 1 column for each of the attributes of my user, so I will start with, I'm just going to copy that for now. I'm going to start with the email and password. So I'll add another column to store the location of the user's profile pic. So I'm going to have one of these classes for each of the tables in my database. I'll add another one for feed items. Then I'm going to create one last table. Oops, caps lock is on again. To store favorites. A favorite is just one user that has favorited another user, similar to friending somebody on Facebook or following them on Twitter. And this just indicates that you would like to see feed items created by that user. So the name of the table is favorites, and it only has 2 columns, and email, which is the user that we're trying to find the favorites for, this user's favorites, and the second column is favorite. So there should be 1 row in this table for each favorite for each user. So for example, if my email address is bobby@mobappdev.net and I do a search on the database for any row that contains my email address, I should get back 0 or more rows in my results, at 1 for each person that I have favorited. So the email address is not unique in this table. It can appear multiple times, but each combination of email and favorite should be unique. I shouldn't be able to favorite the same person more than once. Okay, so this is the schema that I'll be using for my database, and then the next step is to create my OpenHelper, which I'm going to create as a new Java class. I'm going to call it project2OpenHelper. Check this checkbox so Git stops asking me if I want to add everything to source control. I'm going to extend the SQLiteOpenHelper class, which requires a constructor and a couple of methods be implemented, the onCreate and the onUpgrade methods. Just pick one of these randomly. Okay, so a SQLiteOpenHelper has a constructor that takes 4 arguments, but really the only parameter that we absolutely need passed in from outside the class is the context, so an application context or an activity. But we know the database name because this is specified in the schema. We do not need a cursor factory, so we can leave that argument null, and we know the version number because that is also in the schema that I defined earlier. The create method, on the other hand, is called if a database with this name does not exist in the application's private database directory. So if the file name that I specified in the schema, which was project2db, project2db doesn't exist, then the OpenHelper will automatically call the onCreate method so that it'll create a file, it'll create a database that points to that file, and then it'll call the onCreate method so that I have an opportunity to use the SQLite database to create the tables in my schema. So I'm going to do this by calling db.execSQL, and then I'm going to give it a big SQL string that starts with create table with my users table. I'll start, and I'll refer to that as users.name. That's the name of the table that I would like to store my users. And then I like to break this out onto separate lines. But the first thing I'm going to add to the table is a unique ID with the name underscore ID in lowercase. I make it an integer and a primary key for this table, and I'm going to have it auto increment. What this means is that the database will assign a value to each new row that's inserted into the table. The value's guaranteed to be unique. It'll be one larger than the number of the last row that was entered into the database, and it can be used very easily as a primary key. And then I'm going to add a column for each of the columns defined in my schemas. User calls class, beginning with email. And this is just going to be a comma separated list of names. Okay, so when this code is executed against the database, it should create a new table with this name, and then I'm just going to repeat this same procedure to create my other two tables. Okay, so I've gone ahead and created the other two tables, the table for feed items that uses the columns in my schema for feed items, and the table for favorites that uses the columns in my schema for favorites. So I believe this should be sufficient to store all of the data that I need for the application, and the SQLite OpenHelper is finished. So the next class I'm going to create is called a data access object. The textbook that we use with the course tends to mix the data access layer into the model. I don't like that. I like a cleaner separation, so I like all of the database code to be in the database package. So I create a data access object that lives in the database package and provides methods to store and retrieve model objects in the database, and I hide all of that database code inside it. So I'll call it project2 DAO, which is short for data access object. So this object is going to have a SQLite database that will be used to actually access the data in the database. Provide, I would like this to be a singleton. I only want there to be one data access object in the system. So I'm going to create a static instance of the class called project2DAO and set it to null by default. And actually forget that. And then I'm going to create a private constructor that takes a context. Remember, I need a context to create my database helper. The way that you create a database using the database helper, creating the open helper with the context, and then calling get writable database. Then we're going to provide a public static method that returns an instance of the project2DAO class. Again, we need a context just in case the class hasn't been instantiated, the singleton hasn't been instantiated yet. I'm going to need to instantiate it. So I will check to see if singleton is null. If so, I'll create a new project2DAO with the context, and I'll return it. And this is a singleton design pattern, so it should make sure that I only have one of these DAOs in the system. The constructor is private. It does not provide any kind of public default constructor, so there's no way for any class outside of this class to call the constructor to create a new instance of this class. You have to go through the get method, and the get method guarantees that there's only one of these. That's an implementation of the singleton pattern. Okay, so one of the first things I'm going to want to do is actually be able to create a new user in my database. So the very first time a user fires up this application, they're not going to be able to log in because they don't have a username and password. So they're going to use this create account functionality to insert a new user into the database. I'm going to assume that all of the information is stored inside a user object. But before I can insert a user into the database, I need to create what is called content values. Content values, the insert method on the SQLite database takes 3 arguments, one of which is a content values. Content values is essentially a map. It's very similar to a bundle that stores name-value pairs that we use to pass arguments into a fragment, except that in a content values, the name is the name of a column in the table, and the value is the value that's being inserted into the table. So I'm going to create a factory method to create a content values from a user object. Get user content values. So given a user, and I suspect I'm going to need this in more than one place, which is why I'm creating the factory method. Create the content values. And I'm going to add one name value pair for each column in the table. So I'll start, and remember I can use my users.calls to get the names of the columns in the table. I'm going to start by putting the email in. Okay, so I've finished putting the name value pairs into the content values now. So given a user, I will copy all of those values into this content values. One thing I do want to call your attention to is the fact that SQLite doesn't support storing date objects. It doesn't have any way to store a date inside of content values that can then be stored in the database. So typically what is done is the date is converted into a long, which is the number of milliseconds since the epoch, January 1st, 1970 at midnight. And you can get that value just by calling getTime, and then it's very easy to convert a long value back into a date. So before storing the date in the database, you convert it into a long, store the long, and then later when we read it back out, we'll turn the long back into a date. Okay, so in my insert user method, the first thing I'm going to do is actually get the content values for the user that was passed in. And then I'm going to use my database, my SQLite database, to insert a new value into the database. Now, this method takes 3 arguments. The first argument is the name of the table that we're inserting a value, new row into, and I'm going to use my schema to refer to that. The second argument's a little something weird. It's called a null column hack. The reason that this exists is that there's no support in SQLite databases for inserting an empty row, a row that has where every value in the row or every column in the row has no value. So what a null column hack allows you to do, if for whatever reason you want to insert a row in the database that is essentially empty, what a null column hack allows you to do is specify the column into which a null value should be placed. There's a difference between empty and null, right? So a null value gets placed in that column in the event that no other values are specified. So if this content values object up here was actually empty, I could specify a column name here, something like email, and a null value would be inserted into that column in the event that there were no other values to insert. But for our purposes, it's almost always just going to be null because we're never going to try to insert an empty object into the database. And then the last argument are the values that we're inserting. So that's all the code I need. to add a new user to my users table in the database. I'm going to want a similar method for a feed item. And similar to before I can really do anything with this, I'm going to need a factory method that can create a content values from a feed item. Okay, so we've skipped ahead a little bit. Again, I've once again added all of the columns in the feed item table: email, posted date, content, and photo path with the corresponding value from the feed item. I've packed those into the content values and then returned it at the end. Again, I'm treating dates, the posted date for the feed item, in the same way I did for the birth date on the user, converting it into a long, and that's what will actually get stored in the database. My insert, back up in my insert feed item method. Again, it's going to look very similar to the method to insert a user. Pass the item into the get feed item content values method, which generates, which will return that values, and then I'm going to call mDatabase.insert again. Remember, first argument in this method is the table name, so I'm going to refer to feed items.name constant, and the second argument is the null column hack, and then the final argument values that I'm inserting into the database. Finally, I'm going to want a method to add a new favorite to my favorites table. So I'll call it insert favorite. This one's a little different because I don't actually have an object in my model to represent a favorite. Really, all I need is a user, or I might even make it simpler than that and say, give me an email address, and then give me the email address for the favorite that needs to be inserted into the tables. The table, I'm not going to bother to create a factory method for this because it's so easy to just create the content values in line. If I end up having to write this code more than once, maybe I'll create a factory method out of it. Notice that I start typing the name of the table. I'm not typing schema and then favorites. I'm just typing favorites so that I can jump right to it, and then the schema, Android Studio is smart enough to insert the schema in there for me. So I'm going to put the email address in there. And favorites.calls.favorite this time. And then I'm going to insert just like I did before. Again, table name first, favorites.name, null column hack, which I'll leave null, just as I did before, and then the values that I'm inserting into the table. Just like that, I'm able to insert a new favorite into the database. So why don't I go ahead and actually add a method to get a user with a specified email address and password. This can be used to authenticate a user that's trying to log in. So getting a row or rows out of a database is a lot more complicated, unfortunately, than putting a row or rows into the database, and it requires the use of a cursor, which is essentially a pointer. When you query a database, you can get a result set that has 0 or more rows of results in it, and you use the cursor to move from one row to the next and pull the values out of each row before you move to the following row. And most of the time, interacting with, let me just change this to private, it bothers me that it's public. Interacting with a cursor is done through the use of a cursor wrapper class, and it's very common to create custom cursor wrappers that know how to extract the attributes of your model objects out of a cursor and essentially build a new user or a new feed item or whatever from the contents of a cursor so that you don't have to duplicate that code all over the place. And that's done very frequently by creating a custom class that extends the cursor wrapper. So I'm going to create one of those classes. I'm going to make it an inner class inside my DAO, and I'm going to call it user cursor, spell cursor right, wrapper, and it's going to extend the cursor wrapper class. And of course I forgot that it's a class. There's a required constructor here. So I'm going to hit Alt Enter, create constructor matching super. Because the cursor wrapper wraps a cursor, it has a constructor that requires that a cursor be passed in. And then once you have your cursor wrapper, the cursor wrapper actually provides the exact same API that a cursor does. So it has all of the same methods of a cursor. And when you call those methods on your cursor wrapper, it just calls the same method on the cursor. But you can add additional methods. So for example, public user get user. I'm going to use this method to actually pull the values of a user out of one column, assuming that my cursor is pointing at a row in my result set. I'm going to pull the column values out of that result set and copy them into a new user object and then return it. First thing I'm going to do is create a new empty user, and I'll return that at the end. And then this is kind of messy. So for example, I'll set the email. The first thing I need to do, and I'll actually break this out into several lines of code so that you understand what's going on. The first thing I need to do is get the index of the email column inside my cursor. The columns could come out in arbitrary order. They're not necessarily in the same order that I created them in the database, email followed by password, followed by full name, followed by birth date. So I can't necessarily read them in that order. So instead I need to actually get the index, for example, the index of the email column by calling get column index and then giving it the name of the column that I'm looking for. In this case, email. So this returns to me the index in the current row that the cursor is pointing at of the column that has email. It could be the first one, it could be the last one, it could be anyone in there. So then the next thing I'm going to do is actually pull the email address out of the cursor as a string. At that column, so at the email index. So this will pull whatever value is stored in that place inside the cursor out as an email address, and then I'll set it on my user. So typically you don't do this across multiple lines of code. You actually have one longer, nastier line of code, and I'll show you what that looks like as well. Do something like user.set password, get string, get column index, and then column name. And this is the far more typical look of how a cursor wrapper is used. Now remember, every time I make a call on one of the cursor API methods on my cursor wrapper, like get column index or get string, it's actually calling the cursor that I've wrapped. So this method is really just a way, or using the cursor wrapper is really just a way to add a method like get user that knows how to pull the right information out of a cursor to build a user object. So I'll do it again with the full name, using the string that is at column index for the full name column, and so on and so forth. So the next thing I'm going to pull out is the birth date. Now remember, stored the birth date as a long in the database. So I need to get that long back out, and I need to turn it back into a date because my user object actually has a Java util date inside it. So I'm actually going to want to call the constructor on the date object that takes a long, which is again the number of milliseconds since midnight on January 1st, 1970, and I'm going to get a long at the specified column out of my cursor. And just like before, I need to understand the column index that the birth date is stored at. And then I think I have one last, oh yes, my profile pic, which is also a string, which is stored inside the column with the name profile pic. Okay, and you can probably see why I want to wrap this up inside a helper method, a factory method, because I don't want to have to write this code all over the place every single time that I'm trying to get a user out of my database, which is something that I might be doing all the time. Okay, so the fact that we now have a nice cursor wrapper that's capable of pulling a user out of a cursor that we get from the result of querying a database gets us close to where we need to be, but not all the way. So obviously we need to actually query the database. And to do that, we need to call the query method on our SQLite database, and that, as you might expect, returns a cursor. The query method on SQLite database takes a ton of arguments, most of which aren't used most of the time. But the first argument is the name of the table that is being queried. So in this case, it's the users table. And I'm just going to put a comment, table name, next to that. And the second argument is actually the list of columns that you would like to retrieve from the table. So you don't, when executing a query, you do not have to get all of the columns out of a table. You can just grab specific columns that you're looking for. But if you do want every column, you just specify a null value for the second argument. The third argument is the where clause. So the where clause is basically your filter. You use it to indicate how you want the database to decide whether or not a row should be returned as a result of your query. So in this case, the where clause, we want to find only users that have exactly the same email and exactly the same password that we've specified here, which is pretty typical when you log in, when a user logs in. You don't typically want to give a hacker, for example, that's trying to figure out what your username and password is. You don't want to give them finely detailed information about, for example, oh, you got the email right, but you got the password wrong. Instead, you usually just say invalid login, and you leave it up to them to try again. So in that case, you don't actually put the word where in your where clause. It's implied. So you just say something like email equals question mark and password equals question mark. And then the next argument following this is actually the values that should be substituted in place of the question marks. I've mentioned this in class, but this is called a prepared statement, and it's done this way to prevent what's called a SQL injection attack, which is somebody typing an actual SQL query as their username or password when they're logging in, for example, and then if it's formatted in just the right way, it'll actually get executed as part of this query. But when using prepared statements, you put question marks in instead of the actual values that the user typed, and then SQLite will make sure that the value is cleansed before it's substituted in place, which means that it's sanitized so that it won't be treated like a SQL query, and it will not be executed against your database. So the next argument is actually the values that you want substituted in place of the question marks in the same order that they appear in the where clause. And you specify those as a string array, and in this case it's just going to be the email and the password. And for now we're going to ignore the next few arguments, but there are 3 more, and they can potentially be very useful, but we don't need them in this particular case. So the next thing we're going to do is create a user cursor wrapper around our cursor. And then we're going to return. First, we're going to check to see if there are actually any results. So the first thing I'll do is actually ask the cursor to tell me how many results there are. And there should be more than 0 if this user exists. So if this user exists, if there is an entry in the table with the specified email and password that I'm looking for, I'm going to move my wrapper to the first item, the first row in the result set, and then I'm going to assign my user to wrapper.getUser, and I do want to make sure that I actually close my wrapper, whether there is a user or not. If there is 0 rows that have been returned in the result set, I want to return null. This is going to be my clue that that user doesn't exist. And then I want to make sure that I close my wrapper and then finally return the user. So this code, if properly executed, should return exactly one user if that user with the specified email and password actually exists in the database, and it'll return null otherwise.